Welcome to the Virtual Shift, a show looking at the seismic changes happening in healthcare with virtual care at the epicenter. Join me and my guests as we look at key cultural and policy shifts impacting how providers, payers, and patients connect, as well as how care is being reimagined both for today and the future. Hello, and thanks for tuning in today. I'm your host, Tom Foley. You can learn more about this show by visiting the program on healthcarenowradio.com, and be sure to follow me on LinkedIn, Twitter at FoleyTom, and the hashtag The Virtual Shift. And today we have with us Juergen Bayer, Senior Security Advisor for HP. Juergen, welcome to the program.
Hello, Tom. Thanks for having me again.
So, Juergen, we got a very favorable response the last time you were on, so I appreciate you you coming back and talking more about a very important topic, security, and more specifically, the differentiations of an HP device as security is implemented. The last time you were on, we talked about HP's Wolf Security. Just to kind of refresh folks, our listeners, on what HP Wolf Security is, can you give us a kind of a high-level overview of what that is?
Yes, sure, Tom. So for HP, Wolf Security is pretty new in terms of the name. HP Wolf Security is a kind of umbrella brand for all security features our customer sees on our commercial devices. And if we look at the security features, we have to see the device in a holistic way, and they are features we put below the operating system, have features in the operating system, for instance, Windows operating system, and features above the operating system as manageability of the device.
Awesome. So you got these different layers of security within the device itself. Let's break that down. Let's go through each one of those layers and talk to us about the differentiations of that technology. Let's talk first, of the or what's the security in the firmware of the device in and of itself that sits below the operating system.
Yeah, when we look at this layer below the operating system, I think that's a layer which is not so obvious to most of the users of the device, because it is something which the device is not operating in during the operating system is up and running. So it's something the user only experienced during the startup process. So below the operating system, it's interesting because it gives an attacker a way to plant malicious code in the device which is persistent. So even if you remove the system drive, even if you reinstall the operating system, the malicious code is still on the device, so you cannot get rid of it. And because it is below the operating system, it's all the tools running in the operating system would not be able to spot this attack, would not be able to detect this. And thirdly, it gives the attacker a perfect platform because this is the area where they have the most privileges. Planting malicious code at this level gives the attacker the ability to own the device. So overall, very dangerous if an attacker goes at this level.
So, as I understand it, in the firmware, the security mechanism creates these different virtual machines, as I'll refer to them. And within that virtual machine, the firmware makes this determination of good, bad, or indifference of the data flow or the operation of that connectivity. Do I have that right? Can you correct me if I'm wrong? And what is that apparatus in that context?
Yeah, so you're right. Virtual machines are rooted in hardware or in at firmware level. Yes, that's where they start to provide functionality. But we have to go a little bit deeper. So the firmware, that's our interface between the operating system, so that's what the user sees, and the hardware, which the user is using. So, and these two pieces, they need a way to interact with each other, and that's the firmware. And so there are interfaces, or there is code running in firmware at the boot process, but also later when the Windows operating system is up and running, because Windows cannot control the hardware itself. They need this kind of, let's say, proxy, or I would say handlers to support control the hardware, like the charging of the unit, or like controlling the fan. So we deal here with code which is out of reach for Windows. And that's why you need additional protection, which Windows cannot give you. And HP with HP Sure Start gives you the protection.
Interesting. So we're in the firmware. Let's go up as to, you just talked about what Windows can and can't give you, but now we're in the operating system in and of itself. Talk to us about, I mean, it's probably more of a Windows application, but talk to us about the advantages of how HP works with Windows to maximize the effectiveness of a security apparatus.
Well, first of all, Microsoft Windows is a very secure operating system, and Microsoft is doing a great job to even improve security. But there are attacks which are new in the landscape, in the, let's say, in the environment, and we have not seen before. And these attacks, they worry us. So these attacks usually get undetected by all the security software which is installed in the operating system. So how can we protect a device from attacks we haven't seen before? And here comes HP Wolf Security in this picture. And HP, we developed HP Sure Click, which provides isolation technology to the operating system. So what does this mean is, when we look at the attacks, most of the attacks, and I would say more than 80%, come from the internet through emails and attached documents to the emails, or through malicious links sent to a user. So if we can isolate the activities which are connected to this, opening the links or viewing the documents, we can already protect the device at the very beginning from these attacks, even if we don't know the attack, because the activity is happening in isolation. And in isolation, the attack cannot see the host operating system and with all the data.
Interesting. So why is this important when we talk about the virtual shift? And, I would assume because the hospital's enterprise is now exposed, if you will. That might be the wrong word, but in the context of virtual care is not just telehealth, but remote patient monitoring, chronic care management, and soon to be remote therapeutic management. At the end of the day, you have a lot of third-party stuff, if you will, medical devices and computing platforms coming into the enterprise to pass data. And so, it sounds complex for grandmom to be able to use any computing platform. So talk to us about the complexity that sits underneath the hoods and the simplicity that grandma might experience. And I don't mean that in a derogatory sense, but it's the elderly population that is most significant target audience when it comes to chronic care management. So you have to look at the user of the device as whether or not a solution is plausible to be deployed. So at the end of the day, I got virtual care management taking place. I'm extending my enterprise. Talk to me about what I, as an enterprise security engineer, should be concerned about, or how much do I lean on the differentiations of the computing platform that I'm adopting to help simplify or help maximize my security wall.
Yeah, when you talk about bringing or moving a device out of a secure environment into an unknown environment, an external environment, we have to deal with a lot of unknown variables, and of course we know now the device is not necessarily connected to a secure network, or the device is not physically secured, so we don't know who gets access to the device or who tries to get access to the device. So at the end, we have to put more safeguards on the device itself. So the device has to better protect it, and better protection, I mean, not necessarily by an experienced user. The device has to do a lot of the protection by its own. And that's where we with HP Wolf Security also come in, that our devices can secure the data or the device itself by just running the protection, and does not necessarily involve user interaction.
So if I were to interpret what you just said, is that security is a complex matter, but the complexity doesn't have to be transferred to the end user. Is that a fair statement?
Yeah, that's a very fair statement, because security should not prevent the user from using the device and using the device in its intended purpose. And that's where we have to find the balance. So we have to transfer a lot more intelligence, security intelligence on the device itself.
So I have a computing platform, an HP computing platform. I'm looking to deploy this platform into the home because the home is a setting of care. And whether it be the hospital home or the ambulatory home, it's still the home, healthcare anywhere. So I have this computing platform that where the patient is being managed. Yeah, and the patient is being managed because they have multiple chronic conditions and they might have more than one medical device. So the computing platform also acts as I'll just call it a health hub within the home. It's the access point where all the medical devices connect to. So you have downstream devices as well as the interface point for the consumer or the patient to interface with the health system. So I have now this security apparatus embedded into this HP device. Talk to me about how the fact that I have medical devices now connected to it. Again, what's this? How does the Wolf Security help mitigate the flow of unsecured data, if you will? I know I said that wrong, but I have potentially two medical devices, but yet there's a phantom device that's coming in, and it ain't a medical device, but it's pumping data, if you will. How does the HP Wolf Security protect me here?
Yeah. So first, I mean, with all these device applications we're able to manage the health of the patient. That's our main task. But we should not forget we have to manage the health of the device as well.
Yes.
And not only the health, also the status of the device. So only a healthy device can make a healthy patient. And the endpoint device, so the tablet, plays a very critical role, because in this scenario, of course, as you mentioned, it has these external devices connected. So it collects data, and there is a software running on the tablet which transfers this data into a data center. So it's very critical that no malicious code or no attacker gets on this device, because they can see the data from the external component, but they also can see the data center. So they're kind of a man in the middle and would be able to control this communication. So we have to be very cautious that these devices stay safe, because they can expose a point of entry, not only to access the data and manipulate the data, worst case, also to provide or to point of entry into the data center and cause a much bigger problem.
Interesting. If you're just tuning in, you're listening to The Virtual Shift. I'm your host, Tom Foley, and today we're talking with Juergen Bayer, Senior Security Advisor for HP. So let's transition here to a related topic. So we talked a lot about the security of the device in and of itself, the layers in below the operating system and within and above the operating system, and the connection of the devices. So I got this huge enterprise network that I need to protect. But security in and of itself is not, I won't say enough, but there's an extension to your implementation of security, and that's ultimately how do you manage security and how do you manage the device that is extended from your data center. Thoughts on that?
Yeah. So the challenge here to manage the device or to manage the security of the device is usually you operate the device in an environment which is isolated from the internet. But you need these connections from the internet or from the cloud to be able to access the device and to be able to manage this. And this I think this we call modern management. So modern management means we are able to manage devices despite where they are sitting. If they're in a corporate environment or if they're at home, we should always be able to access the device, so to see the status, to perform management tasks, to update software. Also, in the worst case, even maybe to recover the whole operating system. So it is critical that this device is accessible through cloud-based management environment, so we can perform all the tasks necessary to keep the device healthy.
I would imagine in this unfortunate time of COVID, because the enterprise in and of itself has gotten extended. It doesn't matter whether the computing platform is in the home for the purposes of remote patient monitoring or telehealth or chronic care management for that matter, versus the employee in and of itself working from home, right? You're still home. You're still outside of the classic brick and mortar reach of a data center. So the security in some contexts, whether it be on the tablet that grandma and grandpa are using or the employee is using, is still relatively the same. Is that a fair statement, Jurgen?
Yeah, that's absolutely true. But we also, at the same point, we want to heighten security on the device because it becomes more and more important when the device is not operating in a safe environment or shielded by a corporate network, that the device itself can protect the data better. And there's also some tasks like re-imaging device, or as we said with the SureStart, self-healing firmware attacks, which can be very difficult if the device is operated at home, because someone would probably have to access the device physically. And that's what we can avoid with HP SureStart and HP Wolf Security, that device gets in a state which is, let's say, a brick, and service has to come on site for performing the maintenance.
Interesting. So I would also argue that, so while security is relatively the same, right? You have two endpoints that are extended beyond the brick and mortar enterprise. But for added security, because you had referenced earlier that a lot of the attacks come through email attachments and emails themselves. So when you deploy a remote monitoring platform, it's not just an open platform like an employee would have, right? You want to lock it down in the context of allowing just the applications that are necessary to support remote patient monitoring and virtual care to be operational, but not let grandmom's grandson load their favorite video games or their own email apps and go surfing across the web and do whatever you want to do, right? Right. Locking it down is also a security apparatus or a security mechanism in and of itself that makes what we do different than what a general employee might have. Correct?
Yeah, locking down the device is very critical. So only allowed features are visible and can be used. But also we have to see that the device it's operating in a home setup. We do not control the network which the device is connected to. So and not controlling the network, we can also not control who is the device communicating with. And that's the big difference also when we have this device running in an unsecure network compared to a corporate network where we certainly control the network traffic through firewalls and other appliances. Sorry. So it is a different setup, and we have to pay more attention to the device itself. How can we protect the device and the data the device is processing?
Yeah. So the idea here is that it is when you're looking at a computing platform to extend your enterprise and reach into the home, looking at the security mechanisms is very critical. How would you, because it's not, what am I trying to say here? What would you recommend to the security engineer within the enterprise what they should look for when evaluating an endpoint that hangs off their enterprise from a security perspective?
So from a security perspective, there are several things here they can do. First of all, they should secure the device as possible as with standard tools. Let's say make sure that the BIOS settings on the device are safe settings, so and they are secured, so protected with password or other mechanism like HP Sure Admin. But they also should think about when they implement or when they install security software, security-related software, they should have a management console on a central place where they can see the health status or the security status of the device of the device continuously. So they are very aware if, let's say, some security bells going off, that they can take action. So that's this visibility is also very important. And of course, as you mentioned before, we want to lock down the device. So only allowed activities are possible.
It would seem to me that when evaluating devices to be used in this type of application, and one, obviously needing to protect the enterprise, two, making sure that endpoint functions in a way that maximizes that whole enterprise from being protected. So there's a combination of behavior of the end user in and of itself, but you want to make sure that you can maximize your security wall based on what you have in the underlying schema of this computing platform, right? What's in my firmware? What is my firmware speaking to in the operating system? And that maximizes or minimizes the security risk as to what happens above the operating system, right? That user interface and that user behavior. So looking at not just a computing platform and what's the cheapest price is not really the appropriate thing to do, right? There's some underlying very critical enterprise scenarios that we need to look at, especially now with a lot of the attacks on the enterprise and how we can help mitigate that through the appropriate selection of an endpoint. We have only a couple of minutes, a minute or two left. Any thoughts on that last point? And before we go,
you phrased it very right. It's you can implement, you can create a safe application, but it also requires a safe hardware, a safe system running on. So this all goes hand in hand with security, and security cannot be seen isolated, just on data or protecting privacy or protecting a device. It's the big picture you have to look at. And this includes a secure device, secure application, and secure access and transfer of data.
Yeah. I would add that when you select an endpoint, you have to stop looking at what type of, how fast it is, how much memory you have, and how much storage you have. You have to add a fourth component in what's the security apparatus, what's the security mechanism below, in, and above the operating system.
Yeah, very well said.
Okay, awesome. Hey, Jurgen, I very much appreciate your coming on again and having this very important discussion about a very critical topic in healthcare. The title of the program is The Virtual Shift. However, in order for us to make the shift, it has to be done securely, and doing it with HP devices is certainly something that people should look at. It is a differentiated position in the marketplace above and beyond, again, those other three components that we talked about when looking at computing platforms. So again, thank you very much for participating. Hopefully we'll have you on again soon.
Yeah, thank you so much for having me, and looking forward to more.
Awesome. I would like to thank the show sponsors, both HP and Intel. HP Engage long lifecycle products provide the stability, safety, and security you need, plus flexibility and performance designed for today and tomorrow. As well, Intel would like you to know we're going above and beyond together with new standards for business with the latest Intel vPro processors, delivering what IT needs for performance, security, remote manageability, and stability. And be sure to check out the program page on healthcarenowradio.com. And remember, connect or follow me on LinkedIn, Twitter @FoleyTom, and follow the show's hashtag, The Virtual Shift. I'm Tom Foley. Until the next shift.